Yeah, same plan as before. We're going to continue on with the exam. I've got it up from question 4. Once again, you have a copy of the exam plus the solutions if you want to look at those. Starting at question 4 from the top. So, determine the probability of W being greater than or equal to 11. Pretty much a very small portion of what's in the question really matters for this sort of thing. It's good to obviously have the context of what's going on in the scenario, but for the most part, you can pretty much get away with just looking at the actual problem statement itself, and then that already tells you a lot about what you actually need to do. Point 106. 106 is correct. Yeah, absolutely. So we have a look for A. Plenty of things going on there. So we have, firstly, it's normally distributed. We got the mean, we got the standard deviation, and then this is a CDF scenario because you're looking for all outcomes greater than or equal to 11. Lower bound 11, upper bound infinity, mean of 10, standard deviation 0.8. Yeah, fairly standard question. Nice. Part B is also fairly standard. Find the value of k for which 80% of ball speeds are below. There's two key kinds of CAS functions for the normal distribution. This is the other kind of question. You're not looking for a probability, you're looking for a k value, or I guess more specifically something along the x-axis. Probabilities are CDFs, k/x values are the other kind of CAS thing. 10.7, yes, and using inverse normal, correct. That's it. Nice. So, yeah, inverse normal, 80% of ball speeds below, so you want everything left of your K value to be 80%. By default, TI Inspire always points left, so you've got to make sure if you're using a TI Inspire, that's what you do. You make sure it's below or pointing left. For Casio, it doesn't really matter. You can choose whether it's pointing left or right, and you get that flexibility. And then, yeah, same as before. Mean of 10, standard deviation 0.8. 10.7 is the final K value given to one decimal place there. Nice work. Whole bunch of adjustments. Find the mean and standard deviation of P hat. Mean is 0.08. Yep, that's right. So a mean of a sample proportion is going to be purely based off of the proportion P, or the population proportion. So if 8% of balls don't land on the table, then 8% is your mean proportion. Works a bit weirdly, or at least it feels like it works a little bit weirdly for proportion specifically. Standard deviation. Bit harder to type out, given that there's going to be a root in it. Root 46 on 125, yep, that's good. So seeing what both of those look like. Yeah, the expected value, so the mean is just taken straight from the question, no calculation required. That is the p-value for which you sub into your standard deviation formula. Now note that we're using the sampling and estimation version of the standard deviation. And so it's literally just plug and play there. Random sample 25, so your n is 25, p 0.08. Flying through them. Part D, also fairly standard. Binomial distribution to find p hat greater than 0.1. This is kind of redundant because I don't think I've ever seen a question sampling and estimation related where it hasn't been binomial distribution, or at the very least, it's very likely that it's binomial. Well, you solve it with a binomial distribution. So this should be fairly common questions that you solved before. Always one key step involved when it comes to solving sampling and estimation stuff, and that's to somehow convert it to an equivalent discrete statement. Now in this case we know specifically it's binomial, we're literally told it. So we've got to figure out how do we convert this p hat statement into an equivalent x statement. Forgotten that bit. Okay. Well, have you guys got a bound reference on hand? In fact, actually, on the I think it's on the formula sheet. Let's have a look. Yep, sure is. P hat is x on n. That's a very important part of this question. P hat being x on n is one part. The other part is understanding that we're looking at p hat greater than 0.1. So if p hat is x on n, and we're looking for greater than 0.1, well, there's an x in that statement. So if you want to get this in terms of x, it's a fairly quick and easy conversion there. I'll let you have a stab at it. If you're still a bit lost, we'll have a look at the solution. n equals 25, not sure about the x. Cool, that's fine. So all we do there is use the known value 0.1 to help us with our p hat conversion. So basically p hat is x on n, and it's also equal to 0.1. So basically, instead of saying 0.1, I can say x on n. Now, I've kind of just sort of done that in the background, which is just know that if you do 2.5 divided by 25, you get 0.1, so 10%. The other way would be literally just saying 0.1 equals x on 25, multiply both sides by 25, and you get 2.5 for your x value. So basically, the equivalent statement of p hat being greater than 0.1 is x being greater than 2.5. Now you've got to then round that up to 3 because it's binomial, it's discrete. And so you would then do a... I mean, the CAS can also sort of handle it as well. You can see I've still put a lower bound of 2.5, upper bound of 25. But if you wanted to be a bit more, like, a bit better about your working out, you would then rewrite this as probability of x being greater than or equal to 3. So when you round up, you're greater than 2.5, right? You don't just change the value. If 2.5 was in fact your cutoff for being above, then 3 is definitely above that, so it's got to be inclusive. That's all it is. It was a basic algebra solve for that. Anything left to clarify around there? Sweet. This is where they start getting a bit more interesting, at least up until like, yeah, F and G is where they start getting a bit more challenging. We have a piecewise based on the spin setting. So spin is the x-axis, and then obviously the area under the curve is going to be your probabilities. Find maximum possible spin. Yeah, it's just going to be 50. Correct. Spin is on the x-axis, so whatever's the biggest number on the x-axis is therefore the biggest spin. Yeah. Fairly straightforward. Now, technically speaking, this does have a definition outside of 0 to 50, but because it's a probability of 0, because it has no likelihood of occurring, we can't then use that as a valid answer. The weird bit about this is if you do sub in x equals 50 into this, you still get 0. You still use it as the answer because, again, when you're working with those integrals, inclusive or exclusive is treated basically the same. But yeah, flying through them. Next up, median spin. So that'll be something, it's probably not on the formula sheet, but definitely in your bound reference somewhere, I should hope. Median spin in revolutions per second becomes a bit more challenging when you have a 3-stage piecewise. That's something you have to kind of do to work with that. Kind of. You still can, yeah, you can do it all in one, but I found that under certain circumstances, if the piecewise becomes significantly challenging for the CAS to work with, it might break if you try to shove that full thing into one solve. one thing you might want to do would be get a graph. That way you can better observe what's going on with the actual piecewise itself. So you might be doing something like sketching the two, and if you don't like how that looks, you can then also do a bit of domain restriction. 0 to x to 20. And then same with the other one. That's our PDF. Median just means we want to be in the dead center of probability there. Median means we need to solve the upper bound of the integral such that the total area under the curve is equal to 0.5. So if you're to kind of eyeball it just based off of this, the main thing you'd want to do is figure out, am I left or right of the elbow? And if you sort of just like imagine the relative proportion of area on both, it's skewed right ever so slightly. If you imagine the two triangle areas, the triangle on the right is definitely bigger than the triangle on the left. And so with that in mind, we can say for certain that the median is going to occur, or at least we can say with a lot of confidence that the median is going to occur on the second function, not on the first function. That does pose a few more challenges though, because we can't just make our integral equal to 0.5 anymore if we're just looking at the at this right-hand side. We've also got to consider what's going on over here. I won't give too many details of that just now. I'm sure someone will figure out how to handle this bit. I do wonder how much of this could be done on here. Yeah, because you can do bounded area. Not defined. Fair enough. Probably just didn't click the button right. Upper bound is that. Upper bound is that. Yeah, okay, I'm clearly just missing it. Point is, this is definitely less than 50%, whatever's left over here. So whatever remains, if I were to eyeball it, I would say probably that would 50-50 split it. So when you're thinking about how you would actually make that happen, you've actually got two curves you're worrying about that you have to add up to 50%. You've got the area under the first triangle, everything left over there, plus this slither on the right-hand side triangle have to then equal 50% in total for a median. So we then got to figure out, well, how do we do area under a curve? That's just integrals. I reckon at this stage, someone probably has a bit of a better idea of how to go about it. Even if you haven't got an answer immediately, what do you reckon we should do? Are you guys still working on it, or shall I just finish up the answer together? I don't want to take it away from me if I don't have to. Yeah, okay. Let's finish it up. Cool. Okay, so for median, you want the total area under curve to be half. And what you want to do is figure out the last x value for which that happens. Apparently, in this case, defining the full piecewise into the function and then doing exactly this does work, but some other more complicated piecewise is just break. Doesn't work all that well. So what I would do is split it up into parts. I would say, okay, cool. Just by eyeballing it, I'm pretty sure the median is going to be right of that little join to the next function. So if I need the sum of my two areas to equal a half, because you've got two functions, you have to handle them separately, then I'd want to figure out, well, what's the total of my first one? And that is just a quick integral. Right, you're just going the integral of the function over the 0 to 20 domain, and it's going to get you 2/5, which makes sense. We sort of already saw that was going to be less than a half. Cool. So 2/5 or 4/10 is the first area. So the remaining section of it must therefore be 1/10, right? Because you don't want to make up 5 out of 10 or 1 out of 2, right? You want to make up that total bit. And so what you do from there is you say, okay, cool. Definitely starting at 20 on the second function. I don't know where it's going to end, but I do know that that portion of the area has to contribute 1 out of 10 for a total for this to add up to 50%. And then, yeah, that's just a CAS solve. That's going to give you two different solutions, 22.6 and 77.4. One of those is a bad answer because, well, if you have a look at our domain, we're capping at 50. It's not going any further than that. So 22.6 is the only one that makes sense. It is, in fact, to the right of 20, and it is not bigger than 50. Make enough sense now? Is there anything left there to clarify? Otherwise, have a look at G. This one you're going to have to handle in a very similar idea, right? This idea of splitting up the piecewise into two separate sections because there's more valid sections. You'll also have to apply the same idea to this. In fact, I'll just jump in. Let me see on the formula sheet what it actually gives you for it. Standard deviation continuous. Yeah, okay. Don't use this one. Use this one. Because if you try to do the integral x take mean, it's going to be a lot to work with, considering you have to split it across two separate functions. So instead of using that definition of variance, use this definition of variance, e of x squared minus e of x all squared. Now, obviously, the fact that it's standard deviation means you want to root that, but point is use this version of the inside of the root rather than this one, because while they all both work, this will be painful to work with. So use that one. 5 root 28, 5 root 38 on 3, probably. Let me just get that to a decimal place, because you've got to give the final answer to one decimal place. Let's see, 5 root 38 on 3. Yeah, looks good. That's right. As far as how you go about that, square root of e of x squared minus e of x all squared. When it comes to the integral way of doing that, e of x squared, where you have the square on the x specifically, that just means instead of doing x f of x like you would do for regular e of x, you're doing x squared f of x. Now, because there's two parts, you just split it across two parts, right? 0 to 20 of x squared times the function, 20 to 50 of x squared times the function. Then e of x all squared, I mean, that one's a bit easier because you just treat that as regular old e of x. Again, you still have to worry about splitting it up though. But then when you grab that e of x, you just got to square it when you put it into that root. And then, yeah, that's going to come out to 10.3, correct to one decimal place. Nice. That's a solid, yeah, that's a tough one. 3 marks in total. In fact, I better have a look at the the exam report on that. Maybe while you guys have a think of H, I'll pull up the exam report and see how that one would have went for a lot of people, because I imagine it being quite challenging. Yeah, about 32% of people got 3 marks. Still a fairly low percentage thing. This one, however, 2% of people got all marks. This is a tough question. But actually, I feel like we have done one similar to this before. It's got a very similar sort of vibe. This might have been, in fact, if I remember, I think it was 2024. I think 2024 exam had exactly this sort of situation where it was like you had a piecewise of probability, you had A, X, and B, and they had like V and W or some shit on that one. It's actually a repeat of that, basically. Giving you a new median rather than, I think, if I remember correctly, the old one was a new, or the new one, I guess. This is 2021. The first time we saw this, it was a new mean. This time we had a new median. This will test some memory now. If you remember how it was, sold the first time. Find the values A and B. So, two unknowns usually implies two equations with some sort of simultaneous. One of the key information pieces we're given is the median. So one of those equations has definitely got to do with median. I've already seen how to create that before. So splitting up the function into two separate parts, or maybe just looking at the right-hand side function, if that makes it a bit easier. That could help you get the median part of the equation. We just got to figure out where to get a second equation from. Have a play with that for a little bit more. Or is that stuff that you've already done, Uprash?
Like the thing that you talk about with the median, which is, like, what I did was replace the terminal of the integral,
Yep. So instead of having an M there, you have a 30 there.
Yeah, but I'm
Yep.
not really sure what to do next with the second equation.
Yeah, okay. Um, this is where you think about. So one of the nice things about continuous probability is that, in fact, any kind of probability, is there's one thing that's consistent across any time you're doing probability questions, which is that total probability has to add up to one, always. And so you can use that whether it's in a continuous scenario, whether it's in a discrete scenario. That shows up a lot with a free way to give you an equation. So that'll be a second equation that you can work off of. Let me see how that goes. There is also the solutions doc in there if you do want a quick hint before before handing the reins over to me. Another hint I'll give at this stage is watch out for that dilate factor of b. That does do something beyond just sit in the function. It's something that affects x. So think about what else has x in it that could potentially be affected by that b term. In fact, I guess there's a couple of ways you could actually go about this. Having everything add up to one doesn't necessarily have to be one of the equations you use. One of the things that's interesting about this is that because the whole thing is transformed in the same way, and the area under the curve still has to be 1 based off of the fact that it's a probability distribution, the relative proportions of each area remain the same. So for instance, we saw earlier that 2/5 of the probability is on the left-hand side, 3/5 of the probability is on the right-hand side. And so you could also use those equations if you're at all interested in doing so, because the median can be a bit hard to work with given that you're splitting it across two separate functions. Maybe better off using those two instead. Anyone still making decent progress, or shall I take over? Okay, let's do it. Okay, where are we at? So, some initial things we might start thinking about We've got a median equation, and we've got a total area. Has to add up to 1. These are some of the initial things I was thinking about. Now you might note that 50b now becomes the upper bound rather than 50, and that's simply because when you apply a dilate factor to your x, you apply a dilate factor to the x, so it's also got to impact the domain along with it as well. And so basically put, you replace every x with x over b, including the one in the domain. Then finally rearranging to get the x back on its own is the same thing as multiplying both sides of those inequalities by b. 0, of course, is going to stay at 0. I guess for whatever reason, if you do plug this into the CAS, it just sort of carks it, can't really hack it. And so what I've done from there is start by splitting up what a f of x over b actually is. Right, so actually manually simplifying that a little bit for the CAS. And this is what I was talking about earlier, which is, okay, maybe we can't use those, we could use these instead, this was our thing about the median, right, which is instead of saying whole function equals a half, I can do part of the function equals 1 over 10. That's what we had to do when we're doing it somewhat manually before. And then in this case, I've decided to use the 2/5 one. You could technically reuse this function and then do 3/5, because these don't really have anything to do with each other. This is immediate information, and this is just flat out area under the curve information. I guess it's worth pointing out, again, you're going to cut that out at 30. If you do end up doing it this way, remember you've got to put a B on everything else. And the reason there's no there's no B on the 30 is because we're specifically told that that upper bound for median is 30. And then, yeah, this will then just be, you put into a simultaneous equation solver, and I found that was enough to get the CAS to give you a valid answer, or at least a valid answer. It gives you 2 separate ones, one where well, yeah, I mean, you get 2 separate things, so you probably want to do a quick validity check on that, because it says find the values of A and B, not all values or possible values of A and B. And so, how do we actually then check that out? Let's see, what did I write here? We had an old median that was smaller than the new median, so my logic there was, okay, we got to increase speed. And then the way that we increase speed is if b is a number greater than 1. Because when you multiply your x domain, your domain, if you multiply it by a number between 0 and 1, it's going to go smaller, not bigger. And so for that reason, because you want it to go bigger, go faster, the only one that works is if b is actually a bigger number. And so you choose the first pair rather than the second pair. Is there any other way of going about that? Maybe. But that was my rationale behind it. So part of what you'll see in tech actives is that you have to sort of play with the CAS a bit and write it in a way where the CAS can actually work with it, because sometimes the technology does fail. Like this was a scenario where if you did put the full piecewise in there, that was going to it was just not going to do it. Anything left to clarify on what's going on there? Because yeah, this one, in fact, maybe I can find it. Let me pull up the 2024. I think it's in the 2024. It's a very similar thing. If it's not there, then I'll just move on. Damn. I don't remember where it was specifically. It might have even been a non-VCAA exam, but I feel like we have seen this before. Anyway, question 5. Like, does anyone know what I would mean? Like, am I just making this shit up? I've seen this before. Have we looked at this before in maybe a practice sack or a thing? I feel like we've done something similar. If not, let me know and I'll go find it so I can give you another one to practice off of, like after class.
Is the period 4 pi?
Yeah, period is going to be 4 pi here. A couple of ways you could have done that. What was your method?
Just eyeball it.
Yeah, eyeball it. That's good. Yeah, you can spot very clearly. Oh yeah, it's 0 to 4 pi, and even though it's like a little bit off center where the peaks are, it's like consistently off center off of that. And so yeah, you can see from negative 4 pi to 0, it looks identical to when you're doing 0 to 4 pi. It's the same thing. The other way that you could go about that is when you have a sum of circular functions, it's the lowest common multiple of the periods. So instead of just eyeballing it, you could go, okay, period of sine is 4 pi, period of cos is pi, lowest common multiple is 4 pi. But yeah, eyeballing it is perfectly fine as well. Better, even, because you want to be faster rather than slower. Part B is basically free. Minimum value of f. It's even correct decimal places as well, so you got CAS graphing tools to help you out. Heaps of ways you can go about this one.
Is it negative 1.656?
Oh, okay. That's gone a bit off. Maybe. Did you use a graphing tool?
I used fmin.
Fmin. Okay, well that's weird. Did I maybe write the wrong number here then? I've got.
Maybe I don't really use fmin a lot, so maybe I like didn't like input the things in properly.
So it would have been just f of x comma x. There's nothing really crazy to it because that gives you the x value, and then you shove the x value back into f. Let me just check the exam report again to make sure I didn't write my wrong answer here. No, should be negative 1.722. Okay. So f min on this. Let's sort it out. So I haven't got it defined. Let's just grab that. Function equals sine x on 2. If I were to take a guess, you probably have a different function definition. Because f min itself is
I
kind of
didn't
hard to mess with.
define it. I just put it like straight into the thing.
Yeah, I mean, that works too. I tend to define it first because it makes the input look easier.
Yeah.
Um, but it is the exact same thing. Right, so if we do f min, so 7 h of x comma x. Yeah, fair enough. Oh, you just read. Okay, no, you read that. You got to shove that back into function. So fmin and fmax, they give you the x value for which there is a maximum in, and then you
Yeah, my
shove that
bad.
back into the function.
Got you.
Yeah, that's all that was. Um, yeah, I don't know why my like I did a diff equals 0 approach in the CAS, and I guess or in the handwritten in the pre-written notes, and they gave me different x values than this one, but I guess that should make sense because I restricted it from 2 pi to 3 pi just because I looked at the graph, I saw from 2 pi to 3 pi there's a minimum there, which is, yeah, it does the job, I suppose. Yeah, so you got f dash is 0, you got graphing tools, you got f min, whatever you want to get, all those work. Part C is probably one you could eyeball as well, or at least use a little bit of eyeball to approach the answer.
Is it just one?
They're just one.
Oh, and there's another part to a f of h minus x, f of x.
Yeah,
Hold on, let me
yeah,
see.
yeah. Okay. The Kaz is probably going to play a little bit weirdly with this one. At least if you try to Kaz solve it. Like, one of the things I just tried then was to do, um, well, exactly that, which was, hey, okay, f of h take x equals f of x. Well, let's just Kaz solve that for h. I've already used my h, so I just called it a. And whether you enter or control enter, it doesn't really do a whole lot there. This one in particular, you probably need to do a bit more analytically. So observing what actually happens when you do h take x. So for instance, if I print that out, h of a take x, we see a split there. Now that's just been expanded out as compared to the original function, which was that. So we can notice some similarities and some differences there. The idea is saying, okay, what do I have to sub in for my h, or on my Kaz the a, such that they are the same thing. You could potentially slider it as well. Put both graphs on the same axes and then put a slider and eventually get them to overlap each other. Problem with that is it'll give you a decimal. Yeah, it'll give you a decimal. But that decimal, you can probably infer, is going to be some multiple slash fraction of pi, simply because of how it, yeah, simply because of the fact that it's circular functions. That, or you can use symmetry properties, which is to identify, hey, I've got positive cos and positive cos. Cool, I'm sorted there. I got negative sign and that became a positive. Well, sorry, it started as positive sign and it became negative sign. So I got to figure out, okay, what do I have to do to primarily flip sine from being negative back to positive. Now, technically speaking, of course, we also have to worry about the fact that it's different stuff in the cos, but because it's implied already in the question, there is one value it's going to do both. If you focus on solving one of them, you'll get the other. Anyone making reasonable progress, or shall I jump in? Okay. The way I chose to go about it, because of the CAS, I'm going to have to update this. Apparently, CAS doesn't really work out all that well, is to just use the symmetry properties. So, symmetry properties are the things that I was talking about with like the reflections, where you do a little unit circle and you flip it from the first quadrant to whatever quadrant. We want to go from a negative sign to positive sign, or another way to think about that is just going from positive to negative. It doesn't really matter what the direction is. The overall thing is the idea that you have to shift sine by pi if you want to flip it from being positive to negative. If it's in the top quadrant, any shift of pi will put it in the bottom quadrants. Like, that's fundamentally it, whether you go backwards or forwards. And so we want the smallest positive value of h. So we're just going to figure, okay, if I were to shove a h, and we're going to focus on the sign specifically, if I were to shove in a value for h such that when everything simplifies down, I get that plus pi or that minus pi, what am I going to sub in? Well, it's going to be 2 pi. If you put a 2 pi in that spot, you'll get x minus 2 pi on 2, which then simplifies to x over 2 minus pi. Right? Now, that is a positive value of h. Just because there's a negative on it doesn't make it a negative h. It doesn't mean the h value that you choose was negative. It just means what you sub in is what they're talking about there. Any version of pi would technically work, but because you're looking for the smallest positive value, you don't want to go up to 4 pi or 6 pi or anything like that. Which I guess, sorry, it wouldn't, not all those work. You just want the odd pi's. Because if you do any even, you end up back where you started. Point is, that's going beyond the scope of the question. Pick the first and most immediately available one. That fixes sine. You then want to maybe double check making sure the cos is also fixed. If you shove in 2 pi into this spot, expanding this out is going to give you 2x minus 4 pi. Any even integer pi is basically putting you back where you started. So cos of 2 pi, cos of x plus 2 pi is the same as just cos of x. Right, you're starting back to where you started. Same with 4 pi, 6 pi, or any other even integer pi's. One marker, so I imagine it was probably a bit of a separator question. 21% pass rate, yeah, bit tough. If I'm looking at the exam report, 6.28 was what someone had put in. So I'm imagining they probably went the approach of the graphing tool and got some value from that, because you can play with it enough to where the graphs will overlap if you slider it enough times. And then, yeah, I guess the only thing you would have to do from there is recognize the significance of that. You'd probably grab that value, divide it by pi to figure out what fraction of pi you're left with. So let's see how that would work, actually. 6.28 is apparently the number you arrive at if you play with a slider. So if you get 6.28 and you assume that's going to be some fraction of pi, you can see you've basically got two versions, or two copies of pi in there. Obviously there's some error, but if you're playing with your slider significantly well enough to where you're honing in on it, that shouldn't be too far off of the proper fraction that you want. Not great, but better than not getting the mark, I suppose. Yeah. Then what should we do? 3 minutes. Yeah, I reckon we can at least get D. If we've got any time remaining, I'll speed through a few more. Consider the set of functions. Basically, it's the same thing we had from before, but now we have a variable as a coefficient. And we want to figure out that, okay, this will be really easy actually, part D. Figure out what value of A will make this family of functions look exactly like f of x. That'll be fairly chill.
Is it just two?
Yeah, A is going to be 2, right? If you shove a 2 in those spots, shockingly, it's going to look exactly like what we had in the beginning. Yeah. This will also be pretty easy. It's one line in the CAS. I don't even want to spend any time on that. Literally just grab this and shove it in the antidiff and read it and write exactly what you got. You'll notice there's no plus C here. It says find an antiderivative. So if you were to put plus C in there, you would have found all antiderivatives. I don't know if that's necessarily a bad thing if you put a plus C in there. I will just say that the exam report did not have a plus C in there. So I would infer this is a better answer than if you did put a plus C, simply based on that keyword an, rather than find the antiderivative. Though I don't suspect you would get marked down if you put a plus C in there. Okay, we're probably not going to look at this in the next one. We'll probably go on to a new exam. So yeah, let's maybe have a think about this real quick. Definite integral, area bound by the function over this domain is equal above and below. So you want 50-50 split above and below the x-axis, basically. And we're trying to prove that if you do a domain, but do an integral across this, then you'll be, yeah, you'll have exactly that. Do you want to stick around for that, or do you have somewhere to be?
Yeah, I've got to go, but thanks for watching today.
Yeah, no worries. Cool. All right, I'll leave you to it. Take care.